All right, so I'm recording this with my iPhone, so the phone might be moving because I don't have the document camera at home, but I did want to go over how to complete this dilutions and allegation assignment. I think there might have been a misunderstanding from something I said on Monday, but if you were participating and following along, you did not have to submit any work showing that you were participating with the business calculations. That does not cancel out any of the other assignments. So you still have to turn in this one. And the only thing that you don't have to do is submit any of the work that you were doing for that business calculation or that new business section that we were going over. I think it was part 8. All right, so I'm gonna go ahead and start. So for number 1, the way that we solve this is using the dilutions formula that we learned in class. And the dilution formula said that we take a stock volume, multiply it by the stock percent, and it's going to be equivalent to the desired volume times the desired percent. So because we're going to be using this dilution formula, we do need to find out what variables do we have. And for that, we have to look at the problem. So it says an order calls for 120 milliliters of a 10% magnesium sulfate sodium solution. So here, there's a keyword, the order calls. So then this does let us know that this is our desired volume and this is our desired percent. And then it says we have a magnesium sulfate 25% solution. How many milliliters of the 25% do we need? So then this is our stock percent, and then this over here, how many milliliters is our stock volume. So then we could just plug in the numbers into our formula, and then we can go ahead and solve for the unknown value. So we know that we have a stock percent of 25%. And our desired volume is 120 milliliters. And the desired percent is 10%. And our unknown value is the stock volume. So then you would just isolate stock volume, this variable here, by dividing by 25 on both sides. This will cancel out the 25 on this side, and multiply 120 times 10, divide by 25, and then your answer will be in milliliters. And that's all that you do for number 1. Number 2 is actually the same way. It says you are to prepare 50 milliliters of a 1-to-100 rifampin suspension from a stock 1-to-20 rifampin suspension. How many milliliters of the 1-to-20 will you need? So the only difference, or the only way that this problem is now different from the previous one, is that instead of a strength, we have a ratio strength. So let's go ahead and turn this ratio into a percent. And we can do that by just rewriting it as a fraction. So 1-to-100 represents 1/100. So it's like 1 gram of active ingredient over 100. And once we represent it as this, we can go ahead and set it up as a proportion. So we do want to find out how many per 100. So that this one's actually really easy because it's already in 100. So then this solution here is equivalent to 1%. And we'll do the same for the next one. So 1-to-20. So we multiply 100 times 1, it's 100, divided by 20. 20, 40, 60, 80, it's 5. So this should be 5%. I'm not using a calculator, but if I'm mistaken, you guys can correct it. Then now that we know that this 1-to-100 represents a 1% solution, and then a 1-to-20 represents 5%, let's just go ahead and use or put those values there. That way we are aware. So it says that we are to prepare 50 milliliters of a 1-to-100. So again, that word prepare lets us know that this is our desired volume, and then this is our desired percent. And then it says the stock solution is a 1-to-20, which we know is a 5%. How many milliliters of the 1-to-20 do we need? So it's basically the same thing that's asking over here. So go ahead and use the same formula, plug in our known variables, and find out the unknown variable. So our unknown variable again would be the stock volume. So that's what we're trying to find. So you can plug in the numbers and then solve for SV. Question number 3 says a prescription calls for 240 milliliters of a 30% solution of drug B. B is commercially available in strengths of 80 and 20%. How much of the 20% solution will be needed to make the final product? So the difference between this one than what we saw before is that now we don't get we're introducing 2 new strengths. So we're gonna be diluting the 80% and the 20% in order to make a middle percent. So this method for solving number 3 cannot be the same that we used before. It has to be a new one or a different way. So for this one, we do have to set up an alligation method in order to find out how much is needed. For the alligation method, we went over that we need to set it up as a tic-tac. Sorry, I said TikTok. It's as a tic-tac-toe. And then what we do next is on the middle square, you want to put your desired percent. What is it that we're trying to make? So again, it says a prescription calls for 240 milliliters of a 30%. So that means that the 30% is the strength that we're trying to make. And then you put the high strength up here and the low strength up here. High strength was 80%. And then the low strength was 20%. I'm holding the camera with one hand and writing, so I'm sorry if I keep like moving it around everywhere. Now we can go ahead and find the differences. So you do want to find the difference of the 2 numbers diagonally. So the difference between 20 and 30 is 10. And then you find the difference between 80 and 30. So it's just subtraction. So 80 subtracted by 30 is 50. And then once we find the differences, we do want to take the sum of the 2 differences. So you add 10 and 50 and we get 60. And now we can go ahead and these numbers here represent parts. So from the 80%, we're going to need 10 parts of it. And then from the 20% solution, we need 50 parts of it. And this part here represents the total. So both of those combined is going to give us a total of 60, but that's not how much we're trying to make. We're actually trying to make 240. So then let's go back to the problem, because we don't have to do we don't have to solve for both of them. It just says how much of the 20% do we need. So because it's only asking for the 20%, we only need to do this part here. So we want to take the parts that we need of the 20. So we need 50 parts. And then we want to take the total. The total is going to be 60. And then in order to find out how much of this amount do we need, we have to multiply this part over total times the total quantity. And the total quantity here is going to be 240 milliliters. So now you would just divide 50 over 60 and multiply it times 240, and that gives you an amount there. If it had been asking how much of the 80% do we need or how much of each do we need, then you would also do the same for the 80% in order to find it, but the problem's not asking. But I'm just going to go ahead and show you. If it were to be asking for the 80%, you would still use the fraction of the number up here, which was 10, and then the number of the total, which was 60, and then you would also multiply that times 240 milliliters. And then that would give you however much we needed of the 80%. For the rest of the problems, you're also going to do almost the same method. The only differences from some of these other ones is that now you're using these solutions over here. And remember that I included a little guide on the header that tells you what these abbreviations mean. So SWFI means sterile water for irrigation or injection, and that means that it's a 0% strength. And then D10W means 10% dextrose in water, so then the strength here is a 10%. And it wants us to prepare 500 milliliters of 7.5%. So you would do the same setup. This is the high strength. This is the low strength. This is what you're trying to make or your desired. make sure that you're calculating the difference. So find the difference between your desired minus the low, and then over here, your high minus the desired. And then make sure to add both parts. And then once you have all of these numbers figured out, then you can take whatever it's asking for. So this one here is just telling you to prepare it. So then you do need to know how much of the high do you need, high percent needed, and make sure to do part over total. So this is your part, and your total's down here, and then you multiply it times 500 milliliters, which is what you're trying to make. But this, for this problem here, you will need to report both of those values because it's telling you to prepare it. So you need to know how much of each do you need. For the rest of these, this one, I think it's the same thing that we did. I'm like writing with a dark pen, and I think this is 20%. So you're doing the same thing, but this one says prepare 1 liter of a 20% alcohol solution using a 90 and a 10%. So you're going to be doing the same thing that we did up here. Make sure to put the high amount here, the low amount there, desired in the middle, find the difference, add those differences, and then go ahead and set it up as a little equation over here of part over total times whatever quantity they're making. You could leave this in liters, or you could translate it to milliliters, whatever's easier for you. For number 6, what volume in milliliters of sterile water should be mixed with 50% dextrose to make 4.5 liters of 15%? It's the same thing, except here it's just asking for sterile water. So you're only going to calculate for the low percent needed. And remember, it's part over total times the total quantity, which in this case here was 4.5 liters. And you're using 50%, and you're trying to make a 15% from sterile water, which is 0%. For number 7 is going to be a little bit tricky. For number 7, it says how much of the 10% stock solution should you add to 100 milliliters of 0.45% solution to make normal saline 0.9. So the only thing that makes this problem different than before is the end, the fraction that we manipulate at the end. And let me go ahead and work out this problem for you. So for this problem, it says how much of the 10% should you add to the 0.45 to make the 0.9. So the 0.9 is our desired percent. The high amount is the 10%, and then the low amount was 0.45. So again, you have to find the difference across. The difference between 0.45 and 0.9 is 0.45. And then the difference between 10 and 0.9 is 9.1. And then again, we would add those two numbers, so we get 9.55. Okay. And then it's saying how much of the 10% do we need, and we're using 100 milliliters of the 45%. So because it is asking for this one, you would only have to do the top. However, we don't know the total. We don't know the total that we're trying to make of the 0.9. So because we don't know the total, we actually have to calculate how much of the 0.45 we have to take this into account. That way we know how much is the total that we're making. So for the 0.45% or the half saline solution, we set it up the same. So the part there was 9.1 and the total was 9.55. And then we usually would multiply it times the quantity that we're trying to make, but that's actually our unknown variable for this problem. And the total that we are using of this 0.45 solution is actually 100 milliliters. So that's what the problem already told us. So now we have to solve for this unknown here. So just isolate it. You can multiply times 9.55 and then divide by 9.1. Find out how much this quantity equals. And then once you find out this quantity, you're going to set up the fraction the same for the 10% now. So we're going to put 0.45 divided by 9.55. and you're going to multiply it by whatever you found this to be. You put that value here, and then whatever answer you get here is going to be your answer. So remember to solve for this unknown. I don't know if it helps if I like erase quantity and put X, but solve for quantity by multiplying 9.55 times 100 and then divide by 9.1, and then you'll get whatever total it'll be. And then whatever you get here as your quantity, you're going to go ahead and plug it up here and then solve for how much do we need with the 10%. So that's all that you're doing. If you still have some troubles with some of these other ones, let me know and I can go ahead and try to make a little quick video.